we looked at the data modeling. Some of the organizations will also ask for some basic knowledge about SQL. So they don't want you to write complex queries and all. You should be able to at least handle some basic queries on your own. Right? Now, why do you need this when maybe during testing when you're. So last session I talked about data modeling. We understand ER model, how to interpret an ER model, understand what data is stored in our database. I think a couple of things that we need to cover is one thing is we had left the data mapping part incomplete in the interface diagrams. So let's complete that, and I'll also give you some basics about SQL. Okay, so you're not completely dependent on the development team. You can write some basic queries, and you have an idea about how information is retrieved from your databases. Okay. Now, before going into SQL, let's figure out about the data mapping part. Right. So it's a very simple way of mapping your data. All you do is you would link your the data what you want in your interface. So the data point, you will point to that particular attribute and the entity in which it is there. Right? So usually, if you recall, I told you that the data is basically stored in tables. Right? Each entity generally becomes a table, and all the attributes become the columns. Right? Now, if I'm asked to pick up this particular data point, like the physician ID number, right? So I would point to the doctor table dot doctor underscore physician ID number. So this would be the attribute that I'm picking up from, right? So in this case, like if you're picking up all this card related information, so if I have to interpret this, I'm saying that the table card has this information, and you have to look at the attributes: credit card number, expiry date, dot CVV number, dot name. So we are clearly mentioning that these are the data points that these are the attributes that are part of the table card, and we'll have to bring this data from that particular table and attribute. Okay, so make sense now? You're able to understand the data mapping part, or still is it not clear? Just that if you understand the data model, this starts making sense. So since we didn't cover the data model earlier when we talked about the interfaces, I just kept that on hold. Now that we understand the data model, right? So we will have the representation for data mapping in this way. We have the card name, and we'll have the table name, and then the attribute name followed by a dot. Okay. So basically, what we are saying is that pick up the credit card number from this particular table card, and the attribute credit card underscore number. All right, so that's onto the data mapping. I can close on to these documents. I'll give a brief overview about SQL. Okay. Now in this interface, what we're saying that this information is stored in our database: the credit card number, expiry date, CVV number, cardholder name, type of card, and address. All these are already there in our database. The user does not have to enter all that. Okay. So where did you store that in your database? You have to point it out clearly, right? Now the credit card number, I'm saying that it's stored in this particular table card, and the attribute credit card, credit underscore card underscore number. So card would be an entity or a table basically, right? So if you recall your ER diagram also, right? So at the end of it, it's nothing but a collation of tables, right? If you recall from the doctor, patient, and appointment, the hospital management system, we'll have a table for doctor where all the doctors who are there in the hospital will be stored in this table. All the patients which are registered with the hospital will be stored in this table. Any appointment which is created would be stored in this table. Right? So we have these various entities, and each of those entities is capturing some attributes, and that generally is nothing but a table of information. Right? So these are the columns. What you're seeing are nothing but the attributes, right? So similarly, in this case also, here all in this example, what I'm saying is the credit card details are stored in this entity card, and the attributes credit card number is mapped to this credit card number. If you want the credit card number, pick it up from the card table and credit card number attribute. Similarly, expiry date also is one of the attribute in that card table. So map it to that and then pick it up from there. Okay. So you're clearly calling out where that data is stored in your system. Right. So usually if you look at this notation, it's separated by a dot. Right. Yeah. So card means card dot expiry number. So here card is the table name and dot this expiry date is the attribute name. Okay. So this would be the particular column which you'll have to pick it up from. So clear? So sorry, who asked that question? Is that clear for you, or you want me to take one more example?
No, yeah, it is clear now.
Okay. It's quite simple. I think, just that we didn't cover that earlier. We didn't know how data is stored in our databases. We didn't look at it earlier, but it's a very simple exercise. So all you do when you are doing your interfaces is, you'll sit with that ER model. You say, okay, now where is this data coming in from? If your system already is designed, and then you'll have to extract the data from other system. You'll ask for their data model, then you'll look at that data model and then figure out, okay, what data points do we need from this system, right? So which table is it stored, which attribute is it stored? Then you would pick it up and then map it to your data points here. Okay, so that is where your knowledge of your ER models would come in. We've looked at this. Let's look at the basics of SQL, and then we'll move on. So broadly, your SQL is nothing but a language to either store or retrieve data from your database, right? So we are storing a lot of data. How do we create those tables? How do we enter the data into the system, into the database? How do we retrieve it, right? So that's something which your SQL commands would help. So broadly, they are categorized into these 4 types. Data definition basically tells us how to create those tables or create the entities. Okay, so the various tables you'll create using this create, and then if you want to modify or add more attributes to it, all these data definition languages do that. Okay, so data manipulation basically tells how to retrieve data, how to insert data into it, how to delete or how to merge some data, right? All those manipulating data is covered here. Data control language basically gives access to some people, right? So who all can access the database, right? Only some privileged people will be given access. Not all, or not everybody in the organization would have access to all databases, right? So who exactly can access it? So you need to grant access using these commands, grant and revoke. Okay. Similarly, when the transaction is happening, so you want to make sure that you save the transaction once it's completed. You save it in the database. So you commit it, or if you want to roll back a transaction, you can use that using a transaction control, right? So most of these commands, SQL commands, are relevant from a programmer's point of view. We don't really need to know. One thing which we might want to know about is a select statement. Okay. Now, this basically tells us how to retrieve data from our database, right? So the rest of them we are not going to create any tables, because that would be the DBS work, right? So we are not going to give access control to any of the users, or we are not going to commit any transaction or roll back any transaction, right? So that's not our job. Sometimes we might have to use this select command to see whether the data that you have created using the front end has gone and then stored into the database. How do you know whether it's stored in the database? Maybe you use this query language to see whether it's entered into the database or not, right? So Sometimes you would also want to see what are all the data or structure of the table, right? So, you tend to use this select statement for that. Okay. Now, let me give a brief overview. There's a very good site called W3 Schools where you can learn about SQL. In fact, if you want to learn, everything is there in this very good site, I would suggest. But you as a business analyst would not require any of this, right? I'm just giving you an overview about select because some job descriptions ask for basic knowledge of SQL, right? Don't even try to master everything. Learn about just about the select statement and then just that's good enough for you. Even within select, I think the basic syntax is what you need to learn. Because SQL is a very vast topic. There are people who are just doing writing SQL queries and that is their job, right? So don't expect that you will master everything and then you would be required to know everything as a business analyst. That's not the case, right? So let's look at it. Okay. Now, so this is your database. You have so many tables, right? So you have customers, then you have suppliers, you have categories, you have employees, you have orders, order details, the products and shippers, right? So if I just click on this customers, I can see that a customer has these details. There's a customer ID, name, contact name, address, city, postal code, and country, right? So these 7 attributes are there for this customer table, and there are total 91 customers in my table, right? Similarly, if you pick up employee, right? So there are 10 employees, and these are the details that I store: ID, last name, first name, birth date, photo, and notes. Right? If I look at suppliers, so this is the data that is there, right? Now, how do you get this data? Right? So usually the syntax is this: select. You'll use the word select, and star means select all the columns. Now it has 1, 2, 3, 4, 5, 6, 7, 8 columns, right? All 8 columns will be coming in if I say star. From, and what is the table name here? So the table name is suppliers, right? So suppliers is the table. Right? So it will just list. If I run it, it will give me the same query, right? Now if I say if I want to find out all the records in the customer state, say UST from customers, right? If I run it, I'll get all the details about the customer. Okay, so I can pick up only one column also. I say I just want the customer name. Instead of all the columns there, I just want the customer name and city. Okay, so I'm just getting the customer name and the city for all those 91 records. Okay, now I only want the customers who are, let's say, in Mexico or who are in Germany. There. Okay, first let's select all the columns so that now we clearly know what are all the columns. Right? Now I want all the customers where country is equal to Germany. Right? So all I'm done is I'm selecting all the columns, all the records from customers where the country, this particular column, has a value of Germany. Right? Only the customers who are based out of Germany would be listed. If I run, there are 11 customers who are in Germany. That is good enough knowledge for you, wherein you can write your queries with some conditions. I can add more conditions also, like and customer customer ID less than 25. So there are only 3 records. Let's say 50. Okay. So there are 8 records where customer ID is less than 59, right? So it's picking up all the customers from Germany and whose customer ID is less than 50. So you can combine these conditions by using this where and clause, or you can use or clause also. Right? So this condition or this condition. Okay. So you can combine those conditions. You can select the column names rather than everything. You can just select a particular column also. So that's something which you need to know about select statement. I think that is good enough knowledge for you. Okay. So don't waste too much time on this unless they specifically ask in the interviews, in the job description, that you would need SQL knowledge. Don't spend time on this. Right. It's only during the job preparation, interview preparation time, when you look at the job description, they ask for SQL. Then you can brush up your basics on SQL and the select statement and then go. Otherwise, don't waste time on the SQL. Right? So that's not an important point for you. Okay. Right. Now let's move on to the next topic, which is the UML based use cases. Right. Now, so earlier we looked at various documentation techniques, right? And we looked at the structured analysis. Right. Now, none of these none of the the projects or the programming is done using structured way or the procedure oriented programming. Right? People have moved on from the structured analysis to object oriented analysis. So let's get some context about what is object oriented analysis and why UML is used for that, and what is use case. Use case is one of the UML diagrams. So let's get that understanding about what exactly is the link between these object orientation, UML, and then the use case, and then we'll then look at how do we document requirements using use cases, right? So this session will give you a context of why we have started using use cases and moved on from the data flow diagrams. Okay. Now, primarily, if you look at the programming languages, almost all the programming languages these days are object oriented. Okay. So earlier, most of the programming languages were process oriented, which means there used to be a process. Right? So you have to have a step-by-step process that you're doing, and then maybe you'll have a process, and then you try to automate it. They translate it into a system, and then you are working with the system for automating this process, right? So all you did was you document a process and then automate it, right? So that is where your data flow diagrams are very much useful to depict that process. Okay. Now the main problem with this was, if let's say in this process, if one step changes, it's difficult to identify what is the impact of that change, right? So it's all like one large complex system, and one small change you'll have to retest the whole system, right? So it became difficult to maintain those systems, right? And as and when the earlier days, the use of systems was mostly to automate something. You had a manual process. Earlier, everything was done manually in the 70s and early 80s, right? At those time, the intention or objective was just to automate stuff, right? So if you can use a computer to run the payroll, or maybe update the interest, so that was a very much of efficiency that they have gained. So they just focused on that particular process and then automated it. But as and when the processes become complex, it became difficult to maintain those systems, right? So a lot of those systems became unwieldy because the complexity increased. Right? Now, So people started looking out for different ways. Can we move away from the process-based approach and then look at a different way of programming? Which is much more easier to maintain, right? So that is where object orientation gave a different perspective. Okay, object orientation primarily involves the way you look at your real world, right? It simulates the real world. So what happens in the real world? There are multiple objects, right? So everything can be considered as an object, right? So there is a customer, there is an employee, then there is a um, order which is placed, there is a product which is available, right? So in real life there are multiple objects, and then there are interactions between these guys, right? A customer would talk to the employee to get something done. A customer would place a product, right? And then he would pay the bill. The employee would generate the invoice, right? So if you look at the real world, it's nothing but a bunch of objects interacting with one another, and each interaction is independent, right? So if this interaction changes, there is no impact on the on maybe in these interactions, right? So what people thought is, let's simulate the real world in a system, right? So they went for this approach where they identified the objects, they defined what an object is, and then made them interact to actually perform the same task of what we are doing in real world. Okay, so that's exactly is the underlying concept of object orientation. So the main two advantages which came out of it was modularity and abstraction. Okay, now what modularity means is, if I have to put it in simple terms, right? So a large complex system, right? Now it's difficult to understand for one person everything end to end, right? But if I have, say instead of one large big system, if I have smaller systems, right? And each one of them is independent of another one, right? So I can have 5 people work on each one module, and they understand that module in and out, so it's easier to maintain, right? So the complexity is reduced. So since if I change this, the impact on this is very minimal, right? So these two can coexist, right? So there can be 5 people looking at each module each, and then manage a large complex system by breaking it into modules, right? Similarly, the other part is, the modules or objects should be able to interact with one another, right? And then use some functionality, right? Now both these concepts can be easily explained by taking an example of a car, right? So let's say you have a car, you have a problem with your air conditioning. You take it to the mechanic and he would fix it. So are you going to test each and every part of your car, like your suspension, your engine, your gearbox? Are you going to test all of that? Not really. You just test the air conditioning because that was the only thing which was modified, or that was repaired, right? So why? Because you're pretty much sure that if I modify only the air conditioning, the rest of them are not even impacted, right? Why would the engine not work properly if the air conditioning is repaired, right? Why? Because there are all modular parts, right? Engine is completely independent of the air conditioning, right? So that is nothing but modularity. So engine is a different module, air conditioning is a different module, gearbox is a different module, right? So a car, if you consider that as a system, it can be broken down into smaller modules, and each module can handle one specific functionality or feature. Okay. The second concept is abstraction. Now, however modular this car might be, these modules might still need to interact with one another, right? Or for that matter, you also have to interact with the car, right? Now, how would you make the car move faster? Okay. Now, all I need to know is that if I press that accelerator pad, the car moves faster. But is that all? What is happening inside the engine? I don't really need to know, right? Why do I need to know what is happening in the engine? Only the engine needs to know what it needs to do, or the mechanic who is repairing that engine needs to know. All I need to know is how to use it, right? So what we are doing, we are providing abstraction to the functionality, right? So to use a functionality, we don't need to know how it is working internally, right? So all I will do is I'll press on the accelerator pad and the car moves faster. Okay, so there is an interface to that functionality, right? So there is a there is a clear button which is given. I press that button or press that pad, and if I press that pad, I get some functionality delivered, right? So this pad or that button are nothing but your interface, right? So they are hiding that the internal logic of how the engine works through these interfaces. Okay, so effectively what object orientation did was it broke down a large system to smaller modules and allowed them to interact with one another through uh, these interfaces, well-defined interfaces, right? So that basically is the main reason why object orientation is so popular. Okay. Now you can forget everything. This is just for your context. Nobody is going to ask any questions on this or anything. Right? It's just that the more we know, our job becomes easier. Right? So I thought some related topic about why some kind of programming language uh, you know uh, preferred over another one. Right? If you understand this, because your analysis and then documentation techniques would also be aligned to this object orientation. So it makes you do your job better. But again, you won't lose anything if you don't know anything about this, right? So this is more like an additional thing that we have discussed. I've just introduced you to what object orientation is about and what are their advantages over the earlier programming languages. So why was Pascal and Fortran discarded, and then why is Java and .NET widely used? These are the main reasons. Okay. Now again, like I said in the previous screen, I told you that there are objects and they are interacting with one another to perform some process. So how do you define an object? So we define an object by two main things: state and behavior. State is nothing but everything has some data about it, some specific properties. Like if you pick up a car, right? A car would, what is the color of the car? Okay, what is the engine capacity, right? What is the model, right? And various other features that you want to capture about the car. All that would become the data, of the properties, of the state of that particular object. And behavior basically tells what can the object do. What can the car do? The car can move forward, it can move backward, right? It can turn left, it can turn right, right? It can stop, it can accelerate. So these are some of the things which a car can do, right? So together with the state and behavior, we can actually model any real-life object into a software. Right? So we'll figure out, capture all the data, and then we'll clearly define what all it can do. So it's basically defined in your system, right? So that's exactly how we do it. Now, these objects need not be the physical objects, something like a bank account, right? It's intangible, but it still qualifies for the object, right? So a bank account would have information like account number, what is the amount that is stored in the account, right? It would have details about what type of account it is, what is the interest rate on that. So a lot of details that you will maintain. All right. Then uh, you also can do some activities on the account. You can deposit money into the account, you can withdraw money from the account, you can open an account, and you can close an account as well, right? So that is how an object is defined. And the underlying logic of object orientation, like I've explained earlier, you try to model the real world by making the objects interact. Okay, so if I want to develop a banking software, I'll create accounts, I'll get customers, I'll create employees. Now employees can create can start a new account. The customer can deposit money, and we can withdraw money, right? So these are nothing but there are three objects and they are interacting with one another, right? So that exactly is how object orientation works. Okay, now you also keep hearing this term UML modeling, right? So what is UML? UML stands for Unified Modeling Language, but what exactly is it? How is it related to object orientation and our use cases, right? So where does it all fit into this? Now, if you look at any engineering stream, right? Any engineering project that you take, right? You are not directly creating your final product. Right? So either you be it a civil engineering wherein you are constructing a house, or maybe a mechanical engineering and then you're automobile engineering and then you're designing a you're developing a car, right? You're not just going to start the assembly line and then start creating the car right away. What do you do first? You would model the the final product. You will create a replica or a prototype of how the final product would look like, right? Now that could be through a series of diagrams, or it could be a miniature version of your product as well. Why? Because it's easier to work with these prototypes. Even though if you create some errors, that's still okay. You're not wasting too much of money. For example, let's take this house. If you want to construct this house, on day one you'll not start laying your bricks and then or laying your foundation and then starting your construction. You'll not do that. You'll first plan for your house. You'll create these multiple views. What is the front view looking like? What is the top view looking like? What is the side view looking like? Okay, what are those specifications? How high the the wall length should be? Then what is the roof slant? Right? All that has to be clearly documented using these diagrams. Right? Why? Because we clearly have a point of reference. If I give it to the construction worker, you will know, okay, what, this has to be a 10-foot wall, so he'll construct a 10-foot wall, right? He blindly can follow this. So all the thought process goes through in the modeling of this product rather than during the actual implementation. Similarly, in software also, the developers blindly go by what you have designed or the prototypes that you have created. Okay, so they don't do the the thinking, right? So all the thought process is put in by the technical architect and maybe to an extent with the business analyst as well when they are creating these models. Okay, so in software, specifically in object orientation, we model using unified modeling language. Okay, so UML creates a simplified representation of the system using some series of diagrams. So we are not getting into the coding, or we are not actually creating those screens and all, but we are creating some diagrams. There are 9 set of diagrams in UML which try to represent and model how your final system would look like. So all your thinking would actually go in creating these 9 diagrams, and then you give it to the programmers. They would just blindly implement that in a particular technology, let's say Java or .NET, right? But the underlying logic, how these interactions between these objects or what data needs to be passed, all that logic is clearly captured as part of this model. Okay, so that's the connection between object orientation and then UML modeling. Okay, so why this name UML? What does UML means? UML means Unified Modeling Language. Okay. Now, when object orientation started, people were, were excited, and then everybody started their own modeling language. And of late, after some time, people figured out that we have too many versions of modeling language, and it's becoming difficult to track which modeling language to use, right? So what they did was they formed one organization called Object Management Group, which would oversee this UML standard. So they combined all the existing, modeling languages for object orientation which they had, and they created one single modeling language out of all that, right? So the most popular models before UML was there was from Gradibook, Lombard, and then Jacobson. So they picked up the best out of all these models and then created a UML standard, so which has this set of 9 diagrams. Okay. Now using these 9 diagrams, we can actually define how the system would work and think through all those logic and explain all the details, right? So similar to what these views does for a construction of a house, these 9 diagrams does the same for your software. Okay, so all your thinking and then modeling is actually done using these 9 models, and the actual implementation is just a a blind following of these logic what you have listed here in a particular language. Okay, clear till this point in time? Do you get the context of what object orientation is about, what UML is, and where do use cases stand in it, right? So use cases is one of these 9 diagrams. Okay. Now broadly, your UML diagrams are classified into 3 sections, right? Your functional view is coming using the use cases, right? Then the underlying structure of what are all the various objects, how would they interact with one another, which of them can be combined and create one module. All that is considered as structural modules. You are defining the underlying structure of your system, right? Then how do these objects interact with one another, right? How does that object changes state over a period of time? What is the process or control flow? All that is covered as part of your dynamic or behavioral models, okay, which is given by your sequence, collaboration, state chart, and activity diagram. So these various diagrams have different perspective about the system coming out, right? So you'll first define the functionality using the use case diagrams. Then you'll define the the class object diagrams, which will basically define what are all the various objects in your system and all. Then you have the behavioral models, which will show how they interact with one another. So all this is clearly defined by each of these diagrams. So once we have all these 9 diagrams, when we have a fully thought through the system, similar to like when you're constructing a house, you generally have this the front view, then the the side view, right, and then the top view, right? So like only once you have all those 3 views, then you can visualize the 3D object. Similarly, once you have all these 9 diagrams, then you can finally visualize how your final system would look like, which means you have taken care of all aspects of the system. Okay, so now these 9 diagrams are handled by different people, right? You would only contribute to the use cases. So this is where a BA contributes. Business analyst will create the use case diagrams. Okay, the rest of them are mostly done by the technical architect, the person who is designing the system. Okay, now having said that, the use case or the functional models are the first thing which are developed in the system, right? So you play a critical role in ensuring that the requirements are comprehensively captured and correctly captured using the use case. This use case in turn would be used for creating your class, objects, and then the rest of the diagrams, right? So this forms the basis, right? So this would be used as an input for creating the rest of the diagram. So your technical architect is completely dependent on you for what the system should be doing. Okay. So that is some context onto the UML and object orientation. So simply put it, we would capture our requirements using use cases. Right? Use cases is part of UML. UML is used to model object orientation systems.
Like the models are representing like as a diagram.
Yes, most of them are diagrams. Even use cases would also have a diagram, but it would also have some details which will capture as well. Right? So the rest of them are mostly diagrams. Right? So I'll give you a brief overview about that after we understand about use cases also. But we are not involved in any of these. So let's make that very clear. These are something which are owned by a technical architect. Okay. So within UML, you're only confining yourselves to use cases. So we can actually ignore whatever we have learned till now, and then talk about use cases. That would still make sense. But if you have the context, of where your output would be used, right? You'll be able to appreciate that much better and then do a better job, right? So that's the reason I give the context of explaining, overall when you're talking about an object orientation system, what is UML modeling? What is a use case diagram? Where does this overall fit into the big picture? Once you have that bigger view, then you will get into the details about what exactly is expected out of you and what is it that we're doing. So see, again, look at it at a very high level point of view. Don't try to get into the details about how object orientation works and all that, right? So, if I have to crisply summarize what I explained till now, object orientation has some advantages over process oriented languages because, it helps manage the complexity better, right? And how object orientation works, it identifies the various objects and it makes them interact with one another, okay? Then how do you model for your object orientation? You model that using UML diagrams. UML is a set of 9 diagrams, right? And the first diagram is for capturing the functional view. Then there are some 4 diagrams which will help you capture the structural view. And then there are 4 diagrams which will help you capture the dynamic or the interaction between those various objects, right? So this will help you understand the requirement. This will help you list down all your objects and then the modules. Then this will help you in interacting those objects with one another to perform the functionality, right? So, broadly, these are the 3 categories of UML models, right? And we as a business analyst own the use case diagrams. The rest of them are owned by the technical architect. Okay. So when you create the BRD, you would end up writing drawing the use case diagrams and then the use case description for it. Now, again, like Andy was mentioning yesterday, not all projects you would get involved right from the start, right? So there could be some enhancements projects wherein you already have a system built. Maybe they want to make some minor modifications, right? In those kind of situations, you will not go and then draw the use case diagrams and all, right? So use case diagrams are generally used where you're developing a system from scratch, or there are a significant enhancement is being done. Then you'll go and then say, okay, now we need to this is the use case diagram and this is the use case narrative, right? But if let's say there's a requirement wherein you have an existing screen and then you are capturing some set of information, right? Now the customer comes over and then say, what, I want to add these 2 additional pieces data points into my screen, right? So your requirement is very simple. You just add these 2 data points into the screen, and then you'll have to clearly point out, what are all the changes in the screen, and then where this data should be going and stored. Maybe you look at the ER model also if possible, right? Otherwise, you just list down the screen, and then at a very high level you specify that this is a requirement that is there. But if a system is being built from scratch, you generally take that up using a use case diagrams, right? All your requirements are captured using use cases. Okay, make sense? Right. Okay. Now, broadly, use cases has 2 components again. So how do we capture the requirement? There are 2 main things. there is a use case diagram which pictorially represents what is it that we are trying to do in the system. Okay, so this tells that there is a customer who is doing these 5 things using the system, right? We call this as a use case diagram, right? So usually there would be one use case diagram for a system, unless it's too complicated a system, big one. You will break up into modules, and then each module can have one use case diagram. But usually a system tends to have one use case diagram, and you see all these elliptical symbols here. They show what are all the features that the customer or actor, whoever is using the system, for what he would be using the system for. Okay. Now, this itself is not giving us the details, right? If I have to capture the functionality about checking an account balance in a mobile banking app, right? So, the details are not there here. I can just know that, the customer would use it to check his account balance. But how does the overall process happen? What are the steps involved in it? How does the screen look like? What are the backend interfaces required? All that is not coming out here. So what do is we pick up each use case, and then write a use case narrative for it, right? So we'll capture all the details, right? Like, what is the purpose of the use case, what are the preconditions, what is the primary flow, alternate flows, exception flows, the post conditions. A lot of details about each and every use case is captured here, right? So this is the use case diagram. So overall, this is the use case diagram, and these are the use cases. Okay. So every use case would have a use case narrative capturing these details. Okay. So you end up with, if there are like 5 use cases in it, you will end up with 5 use case descriptions capturing all these details for each one of them separately. Okay. So that is how you would approach your requirements. Okay. So we briefly covered about these preconditions, primary flow, alternate flow, exception flow, when I was talking about the elicitation techniques. How do you know that the requirement is complete? What all details you need to capture, right? I said that you should ask questions on what are all those preconditions, then what is the primary flow events, alternate flow events, right? So that's the kind of questions that you ask is broadly based on the use case description. So if you can come back and then fill in all these details, you can be pretty much sure that you've captured all the details about the requirement, right? So that is the structure for a use case. Now we will we'll go through that in detail in tomorrow's session about how to draw the use case diagrams for a particular requirement. How do we write the description for that? Right? We'll pick up some small examples and then understand it in detail in tomorrow's session.